Okay, electron pair geometry is the geometry taken up by all the valence electrons around the central atom. So we would be looking at all of the valence electrons, so the dots and the lines, but only around the central atom, not caring about what's going on the outer atoms. And there are only 5 choices for this. Those are the 5 that we wrote down on the previous page: linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. Molecular geometry, however, describes the arrangement in space of the central atom and the other atoms attached to it. Okay, and we're going to start by talking about 4 electron domains. What about when we have 4 electron domains? Well, if there are 4 electron domains and they all have bond pairs, it will be tetrahedral, just like we said before, and the molecular geometry will be called tetrahedral. That's when you have 4 bond pairs, no lone pairs. And the picture, same as what we drew on the previous page, will look like that. The bond angle will be 109.5, and an example would be CCl4, would fall under that. But what if instead one of these was not an atom? There's no atom here. Instead, this is a lone pair of electrons, just 2 dots in that location. And so it wouldn't be taking up the same kind of space because it's just a pair of electrons instead of there being a nucleus of another atom out here. So it would look like this, and we call this trigonal pyramidal. And that is what you get when you have 3 bond pairs, 1 lone pair, and it'll look like this. You get kind of looks like an umbrella. And the bond angle here will be 107. And the reason it's 107 is its lone pair is very pushy. It's got electrons, no protons, nothing to balance it out, so it will push away these other bond pairs. So the bond angles between the others will be closer. And this is something like NH3 would fall under this example, because when you draw the Lewis structure for NH3, you would have 3 H's and then a pair of dots up there, so that represents that. Then, if you took even an additional one away, it would be 2 bond pairs, 2 lone pairs, and it's something called bent. And the bond angle there is about 105 degrees. And this is something like water, where there's 2 sets of dots, and that pushes the hydrogens closer to each other, so that's bent there. Okay, so then we want to record that on our chart here. So we have underneath our EPGs, we're going to propose our possible MGs. This first line is going to be when there are no lone pairs. And when we have tetrahedral with no lone pairs, it's going to still be called tetrahedral. When we have with 1 lone pair, it's going to be called trigonal pyramidal. And when we have 2 lone pairs, it's going to be called bent. Okay, so we did the tetrahedral, and before we go on to page 21 on our notes, I want to talk a little bit about linear and trigonal planar, because there's not a place on our notes where we're going to go through that. So let's take a look at our trigonal planar version. Okay, if you had 3 domains of electrons and they're all bond pairs, it would look like this, and it would be trigonal planar. If instead you removed one and had 1 lone pair, it would now be bent. but the bond angle would be 120. This one has a bond angle of 120, whereas this bent has a bond angle of 109.5. So those two bents are different than each other. For linear, if you have two electron domains, both bond pairs, it's linear. As soon as you go down to having just two atoms, that would be this case. If you had just two atoms, it's always linear. In this case, if you had removed another bond pair and now it was just two atoms, it would be linear. The same would have been true with this. So there's kind of like a secret linear here, here, and here that like once you get down to two atoms, they're always in a line. So that is how that goes. So we've got 2, 3, and 4 electron domains we've discovered. So let's look at the top of 21 and see if we can figure out what are the shapes of H3O plus and ClF2 plus. And if you're doing this at home, you probably want to pause the video and see if you can do it and then check to see what I say. Okay, so this is the Lewis structures for both of them. So I say that this has 4 electron domains. 1, 2, 3, 4. So the EPG is tetrahedral. But the MG, the molecular geometry, I have 3 bond pairs and 1 lone pair. 3 bond pairs and 1 lone pair corresponds to trigonal pyramidal. This one has 4 electron domains, 1, 2, 3, 4, so the EPG is tetrahedral. The molecular geometry, well, we have 2 bond pairs, 2 lone pairs, so 2 and 2 was bent. Now let's do BF3 and BF4. BF3 looks like this. BF4 now both of these are made with boron, but this one has 3 domains, 1, 2, 3, so the EPG and MG both are trigonal planar. But this one has 4 domains, so the EPG and MG are both tetrahedral.